India is spending over 20,000 crore rupees on a single mission. But here's the shocking part. It's not a satellite or a rocket launch. It's 3 human lives sent into orbit, riding on a machine that must deliver 99.8% reliability or face disaster. This isn't just another milestone. It's a gamble where everything depends on technology that has never yet carried an Indian to space under our own flag. And the question that matters is this: will Gaganyaan succeed or fail when it matters most? Before we move into that, would like you to subscribe to the channel and like the video. Imagine the rocket thundering off the pad, and within seconds, an explosion tears the sky open. That's the nightmare everyone thinks about but hopes never happens. A launch is the single most dangerous part of any space mission. For the astronauts on board, it isn't a slow climb, it's a violent sprint, pushing them with crushing forces while tons of highly pressurized fuel roar beneath their feet. If anything goes wrong at that moment, the outcome is almost always catastrophic. The margin for survival is so small that human reaction time alone simply isn't enough. Once committed to the sky, there is no way to press a pause button. Think of it like being locked into a racing car that is already flying past maximum speed. The track ahead may crumble instantly, and you only survive if an escape system works perfectly. Without it, the car just hurtles forward until destruction. Spaceflight is no different. Astronauts must trust a mechanism that can pull them away in a fraction of a second if disaster strikes. It can't hesitate, it can't debate, and it certainly can't wait for a human to press a switch. In those milliseconds, machines make the call, and lives depend entirely on automated precision. India's space agency knew this risk from the start. Before even finishing designs for the full spacecraft, engineers wrestled with the worst-case scenario. How do you save the crew if their rocket suddenly turns into a fireball? Their answer was the Crew Escape System, or CES. This system stands like a tower strapped to the top of the crew module. Inside it are small but powerful solid-fuel rockets designed with only one job: pull the astronauts away at violent speed and carry them to safety. This isn't just theory. In July 2018, ISRO tested the escape system in what is known as a pad abort test. A real capsule was yanked away from a launch pad by the escape rockets, climbing high into the air before parachutes brought it back down safely. Then, in October 2023, they went further with an in-flight trial called TV-D1, simulating the terrifying moment when a booster fails mid-flight. The system worked as expected, kicking the capsule clear of potential disaster. These events weren't just trials of equipment. They were rehearsals for survival under the worst possible day in spaceflight. And when you think about it, astronauts aren't only placing faith in the rocket taking them to orbit, they're also placing faith in the very machines designed to save them if everything unravels. Every reaction is automated, every movement timed down to fractions of a second. Years of planning comes down to trusting an instant sequence of violent jolts and parachute drifts. It's dramatic, yes, but it's also the silent promise to the crew that even if the rocket beneath them fails spectacularly, they still have a way back. And that raises the next challenge. If the machines are built to snatch astronauts away from destruction, how do you prepare the humans themselves to survive what comes after? What does it take to prepare someone to leave behind gravity, air, and normal human limits? The answer is not just training, it's transformation. Astronauts aren't born ready for space, they are shaped by years of trials that push them to the edge of endurance. For Gaganyaan, ISRO chose its candidates from a pool of test pilots and defense aviators, men already accustomed to high speed, pressure shifts, and danger. But flying a fighter jet at supersonic speed is still grounded within Earth's limits. Space strips away even those familiar rules, demanding resilience no ordinary skill set can guarantee. Skill itself is only the starting line. The process to become flight-ready slices beyond talent and requires mental toughness under circumstances most people could barely imagine. Imagine being sealed inside a capsule mock-up for days at a stretch with nothing but recycled air and minimal sound. The body reacts in strange ways. Some people panic, some lose focus, and some become disoriented. The tests are harsh because the real flight leaves no tolerance for weakness. Stress on the ground acts like a filter, exposing every crack before it can become a threat in orbit. One of the most telling examples comes from survival exercises outside India. In the forests of Russia, candidates faced freezing conditions while practicing how to endure an emergency landing away from civilization. Hours turned into days as they learned to survive without regular shelter or supplies, building fires in snow-covered terrain, rationing limited food, and dealing with the psychological weight of isolation. These scenarios weren't play acting. They mirrored possible outcomes if a capsule returned off course and astronauts had to hold out until rescue. Back home in Bengaluru, another test unfolded. Confinement inside low-space habitats that recreated both the claustrophobia of orbit and life systems astronauts must depend on. Every detail was monitored, from oxygen saturation to how the crew worked as a team under artificial silence. The tough part of this isn't the machines, it's the human response to being cut off from the world while your environment defines every breath you take. It's like forging steel. Each attempt exposes weaknesses, but those who endure emerge harder, sharper, and unyielding. Medical specialists watched carefully through every stage. Electrodes traced heart rhythms to see how stress built up under pressure. Radiation exposure tolerance was studied, since particles invisible to the eye become a reality outside Earth's shield. Even something as subtle as silence itself, the absence of Earth's constant background noise, was evaluated to spot signs of psychological breakdown. Because nothing is left to chance, doctors have to know how bodies and minds bend before they can break. At Russia's Gagarin Cosmonaut Training Center, Indian candidates joined a program shaped by decades of human spaceflight experience. This collaboration showed the recognition that while Gaganyaan is India's step into crewed missions, trust in tested methods builds an extra safety net along the way. Then, in February 2024, the process reached an emotional peak when 4 Air Force officers stood revealed as astronaut designates. For the public, it was a proud moment. For the candidates, it was only acknowledgement of uncounted hours pushing human limits. Behind every training suit lies a person already tempered by extremes before touching the spacecraft itself. Now the next puzzle waits. What vessel will carry them into orbit? How do you design a spacecraft when failure equals death? That's the question ISRO had to face when it started building India's first human space vehicle for Gaganyaan. At the center of the plan is what's called the orbital module, and it's split into 2 vital parts: the crew module and the service module. Together they form a system that can take people into orbit, keep them alive while they're there, and then return them through the most hostile conditions a machine can endure. The challenge lies in balance. The craft must be light enough to ride a heavy rocket into space, yet strong enough to survive the furnace of re-entry, a descent that heats the outside to temperatures hotter than molten metal. If it's too heavy, the rocket won't manage. If it's too weak, the crew won't make it back. So ISRO had to engineer something in between, a compromise that still delivers full protection. You could think of it like taking a lifeboat, wrapping it in fireproof armor, and then strapping it on top of a tower of fuel. The lifeboat shields its passengers, while the service module beneath powers the voyage with engines, batteries, and solar panels stretching like wings. Inside the crew module, every detail speaks to survival. Layers of insulation and life support systems pump oxygen, control humidity, and filter out carbon dioxide so the closed cabin can act like a miniature Earth. The heat shield underneath is built to withstand fiery entry at many times the speed of sound, shedding layers to absorb the brutal force of atmospheric friction. Parachutes packed into compartments will slow the capsule from a supersonic dart to a safe ocean splashdown. Even the seats are designed to absorb shocks, tilting and cushioning the astronauts' bodies so that landing forces don't cause injury. Nearby, rations, water packs, and emergency equipment make sure that if recovery teams arrive late, the crew can endure those extra hours or days, and the roadmap puts safety above speed. Instead of rushing people into space, ISRO will send 3 uncrewed flights first, including Gaganyaan 1, with Vyamitra on board. Each flight becomes a rehearsal, checking every piece of the system again and again. Only if those steps succeed does the real mission unfold. The target sits in early 2027. 3 Indian astronauts spending several days in low Earth orbit, watching their homeland from above as the tricolour flies with them. And from there, the horizon only widens, because if this ship holds up, the question becomes what new opportunities India will chase in space exploration. Gaganyaan is more than a spacecraft. It's India's entry into the long game of human space exploration. Every trial, every simulation, and every test is an opening move in a century where new nations will step beyond Earth. The mission isn't just about planting a flag in orbit, it's about proving that space belongs to more than a handful of countries. Do you think India will meet its 2027 target? And if it does humanity benefit when new players join the frontier? The countdown to history has already begun, and the next names may soon rise with the sky. That's it for today's episode. Thanks so much for watching. If you enjoyed it, don't forget to hit that like button and subscribe so you don't miss what's coming next. We've got plenty more mysteries to uncover together. See you in the next one.